Hello and welcome to this screencast which explains how to calculate coupling constants in proton NMR spectra. Calculation of coupling constants enables us to gain information on regiochemistry within molecules, for example whether alkenes are cis or trans, or whether a disubstituted benzene is ortho, meta or para disubstituted. The coupling constant is the distance between lines in a multiplet measured in Hertz. However, peaks in proton NMR spectra are usually labelled in ppm, so how do we calculate the coupling constant? Let's look at an example. This signal arises from one aromatic proton which has two different neighbours, so appears as a doublet of doublets in the spectrum. It couples to one neighbour with a large coupling constant and another neighbour with a small coupling constant. To calculate the coupling constant, the first step is to calculate the line spacing in ppm, as this can be done straight from the spectrum. Let's look at the large coupling constant first. Strictly speaking, the large coupling constant is the distance from the middle of one doublet to the middle of the other. However, to save some calculation steps, we can calculate the distance from the left-hand peak to the other left-hand peak. Or we could use the right-hand ones. We should get the same answer. To calculate the line spacing, we just need to subtract the smaller value from the larger one, i.e. 7.9459 minus 7.9304. This gives us a line spacing in ppm of 0.0155 ppm. Now we need to convert this value to Hertz. To do this, we need to know what frequency of NMR spectrometer was used to record the spectrum. In this case, a 500 MHz machine was used. On a 500 MHz instrument, 1 ppm corresponds to 500 Hz, so 0.0155 ppm corresponds to 0.0155 times 500 Hz, which equals 7.75 Hz. So this is the line spacing in Hertz, in other words the coupling constant. As this is an aromatic proton, this corresponds to an ortho coupling to a neighbouring hydrogen. Now let's follow the same steps to calculate the small coupling constant. This time we're measuring the distance between the left and right hand peaks of one side of the doublet of doublets. The calculation steps are exactly the same, so we get a line spacing in ppm of 0.0033 ppm, which converts to a coupling constant of 1.65 Hz. This corresponds to a meta-coupling. It's important to know which line spacings you should be measuring for different multiplets. In simple cases, there'll be only one line spacing to calculate, so in a doublet you should be measuring the distance between the two lines, and in a triplet you should measure from the central line to one of the outside lines. You should get the same answer either way. In more complex cases there may be two coupling constants to calculate, as we've seen. Here are some more practice questions. The answers are shown at the end, so you might want to pause the screencast while you have a go. Thanks for watching, and look out for more resources coming soon on the Analytical Science Tutor channel.